Aphorisms 14 to 20 of Book 2 of the New Organon. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Morgan Scorpion. The New Organon by Francis Bacon. Translated by James Spedding, Robert Leslie Ellis, and Douglas Denon Heath. Aphorisms 14 to 20 of Book 2. 14. How poor we are in history anyone may see from the foregoing tables, where I not only insert sometimes mere traditions and reports, though never without a note of doubtful credit and authority, in place of history proved and instances certain, but am also frequently forced to use the words, let trial be made, or let it be further inquired. 15. The work and office of these three tables I call the presentation of instances to the understanding. Which presentation having been made, induction itself must be set at work, for the problem is, upon a review of the instances, all and each, to find such a nature as is always present or absent with the given nature, and always increases and decreases with it, and which is, as I have said, a particular case of a more general nature. Now, if the mind attempt this affirmatively from the first, as when left to itself it is always wont to do, the result will be fancies and guesses and notions ill-defined, and axioms that must be mended every day, unless like the schoolmen we have a mind to fight for what is false, though doubtless there will be better or worse according to the faculties and strength of the understanding which is at work. To God, truly the giver and architect of forms, and it may be to the angels and higher intelligences, it belongs to have an affirmative knowledge of forms immediately and from the first contemplation. But this assuredly is more than man can do, to whom it is granted only to proceed at first by negatives, and at last to end in affirmatives after exclusion has been exhausted. 16. We must make, therefore, a complete solution and separation of nature, not indeed by fire, but by the mind, which is a kind of divine fire. The first work, therefore, of true induction, as far as regards the discovery of forms, is the rejection or exclusion of the several natures which are not found in some instance where the given nature is present, or are found in some instance where the given nature is absent, or are found to increase in some instance when the given nature decreases, or to decrease when the given nature increases. Then indeed, after the rejection and exclusion has been duly made, there will remain at the bottom, all right opinions vanishing into smoke, a form affirmative, solid and true and well defined. This is quickly said, but the way to come at it is winding and intricate. I will endeavour, however, not to overlook any of the points which may help us toward it. 17. But when I assign so prominent a part to forms, I cannot too often warn and admonish men against applying what I say to those forms to which their thoughts and contemplations have hitherto been accustomed. For in the first place, I do not at present speak of compound forms, which are, as I have remarked, combinations of simple natures according to the common course of the universe, as of the lion, eagle, rose, gold, and the like. It will be time to treat of these when we come to the latent processes and latent configurations, and the discovery of them as they are found in what are called substances or natures concrete. And even in the case of simple natures, it would not be understood to speak of abstract forms and ideas, either not defined in matter at all, or ill-defined. For when I speak of forms, I mean nothing more than those laws and determinations of absolute actuality which govern and constitute any simple nature, as heat, light, weight, in every kind of matter and subject that is susceptible of them. Thus the form of heat, or the form of light, is the same thing as the law of heat, or the law of light. Nor indeed do I ever allow myself to be drawn away from things themselves and the operative part. And therefore when I say, for instance, in the investigation of the form of heat, reject rarity, or rarity does not belong in the form of heat, it is the same as if I said, it is possible to superinduce heat on a dense body, or it is possible to take away or keep out heat from a rare body. But if any one conceive that my forms too are of a somewhat abstract nature, because they mix and combine things heterogeneous, for the heat of heavenly bodies and the heat of fire seem to be very heterogeneous, so do the fixed red of the rose or the like, and the apparent red in the rainbow, the opal, or the diamond. So again do the different kinds of death, death by drowning, by hanging, by stabbing, by apoplexy, by atrophy, and yet they agree severally in the nature of heat, redness, death. If any one, I say, be of this opinion, he may be assured that his mind is held in captivity by custom, by the gross appearance of things, and by men's opinions. For it is most certain that these things, however heterogeneous and alien from each other, agree in the form or law which governs heat, redness, and death, and that the power of man cannot possibly be emancipated and freed from the common course of nature, and expanded and exalted to new efficients and new modes of operation, except by the revelation and discovery of forms of this kind. And yet, when I have spoken of this union of nature, which is the point of most importance, I shall proceed to the divisions and veins of nature, as well the ordinary as those that are more inward and exact, and speak of them in their place. 18. I must now give an example of the exclusion or rejection of natures which by the tables of presentation are found not to belong to the form of heat, observing in the meantime that not only each table suffices for the rejection of any nature, but even any one of the particular instances contained in any of the tables. For it is manifest from what has been said, that any one contradictory instance overthrows a conjecture as to the form. But nevertheless, for clearness' sake, and that the use of the tables may be more plainly shown, I sometimes double or multiply an exclusion. An example of exclusion or rejection of natures from the form of heat. 1. On account of the rays of the sun, reject the nature of the elements. 2. On account of common fire, and chiefly subterraneous fires, which are the most remote and most completely separate from the rays of heavenly bodies, reject the nature of heavenly bodies. 3. On account of the warmth acquired by all kinds of bodies, minerals, vegetables, skin of animals, water, oil, air, and the rest, by mere approach to a fire or other hot body, reject the distinctive or more subtle texture of bodies. 4. On account of ignited iron and other metals which communicate heat to other bodies and yet lose none of their weight or substance, reject the communication or admixture of the substance of another hot body. 5. On account of boiling water and air, and also on account of metals and other solids that receive heat but not to ignition or red heat, reject light or brightness. 6. On account of the rays of the moon and other heavenly bodies, with the exception of the sun, also reject light and brightness. 7. By comparison of ignited iron and the flame of spirit of wine, of which ignited iron has more heat and less brightness, while the flame of spirit of wine has more brightness and less heat, also reject light and brightness. 8. On account of ignited gold and other metals, which are of the greatest density as a whole, reject rarity. 9. On account of air, which is found for the most part cold and yet remains rare, also reject rarity. 10. On account of ignited iron, which does not swell in bulk, but keeps within the same visible dimensions, reject local or expansive motion of the body as a whole. 11. On account of the dilation of air in calendar glasses and the like, wherein the air evidently moves locally and expansively and yet acquires no manifest increase of heat, also reject local or expansive motion of the body as a whole. 12. On account of the ease with which all bodies are heated without any destruction or observable alteration, reject a destructive nature, or the violent communication of any new nature. 13. On account of the agreement and conformity of the similar effects which are wrought by heat and cold, reject motion of the body as a whole, whether expansive or contractive. 14. On account of heat being kindled by the attrition of bodies, reject a principial nature. By principial nature I mean that which exists in the nature of things positively, and not as the effect of any antecedent nature. There are other natures beside these, for these tables are not perfect, but meant only for examples. All and each of the above-mentioned natures do not belong to the form of heat, and from all of them man is freed in his operations of heat. 19. In the process of exclusion are laid the foundations of true induction, which however is not completed till it arrives at an affirmative. Nor is the exclusive part itself at all complete, nor indeed can it possibly be so at first, for exclusion is evidently the rejection of simple natures, and if we do not yet possess sound and true notions of simple natures, how can the process of exclusion be made accurate? Now some of the above-mentioned notions, as of the nature of the elements, of the nature of heavenly bodies, of rarity, are vague and ill-defined. I, therefore, well knowing and nowise forgetting how great a work I am about, viz., that of rendering the human understanding a match for things and nature, do not rest satisfied with the precepts I have laid down, but proceed further to devise and supply more powerful aids for the use of the understanding, which I shall now subjoin. And assuredly in the interpretation of nature the mind should by all means be so prepared and disposed, that while it rests and finds footing in due stages and degrees of certainty, it may remember withal, especially at the beginning, that what it has before it depends in great measure upon what remains behind. 20. And yet, since truth will sooner come out from error than from confusion, I think it expedient that the understanding should have permission, after the 3 tables of first presentation, such as I have exhibited, have been made and weighed, to make an essay on the interpretation of nature in the affirmative way, on the strength both of the instances given in the tables, and of any others it may meet with elsewhere. Which kind of essay I call the indulgence of the understanding, or the commencement of interpretation, or the first vintage. First vintage concerning the form of heat. It is to be observed that the form of a thing is to be found, as plainly appears from what has been said, in each and all the instances in which the thing itself is to be found, otherwise it would not be the form. It follows therefore that there can be no contradictory instance. At the same time the form is found much more conspicuous and evident in some instances than in others, namely in those wherein the nature of the form is less restrained and obstructed, and kept within bounds by other natures. Instances of this kind I call shining or striking instances. Let us now therefore proceed to the first vintage concerning the form of heat. From a survey of the instances, all and each, the nature of which heat is a particular case, appears to be motion. This is displayed most conspicuously in flame, which is always in motion, and in boiling or simmering liquids, which also are in perpetual motion. It is also shown in the excitement or increase of heat caused by motion, as in bellows and blasts, on which see Table 3, instance 29, and again in other kinds of motion, on which see Table 3, instance 28 and 31. Again it is shown in the extinction of fire and heat by any strong compression, which checks and stops the motion, on which see Table 3, instance 30 and 32. It is shown also by this that all bodies are destroyed, or at any rate notably altered, by all strong and vehement fire and heat, whence it is quite clear that heat causes a tumult and confusion and violent motion in the internal parts of a body, which perceptibly tend to its dissolution. When I say of motion that it is as the genus of which heat is a species, I would be understood to mean, not that heat generates motion, or that motion generates heat, though both are true in certain cases, but that heat itself, in essence and quiddity, is motion and nothing else, limited however by the specific differences which I will presently subjoin, as soon as I have added a few cautions for the sake of avoiding ambiguity. Sensible heat is a relative notion, and has relation to man, not to the universe, and is correctly defined as merely the effect of heat on the animal spirits. Moreover, in itself it is variable, since the same body, according to the senses I've predisposed, induces a perception of cold as well as of heat. This is clear from instance 41, Table 3. Nor again must the communication of heat, or its transitive nature, by means of which a body becomes hot when a hot body is applied to it, be confounded with the form of heat. For heat is one thing, heating is another. Heat is produced by the motion of attrition without any preceding heat, an instance which excludes heating from the form of heat. And even when heat is produced by the approach of a hot body, this does not proceed from the form of heat, but depends entirely on a higher and more general nature, viz., on the nature of assimilation or self-multiplication, a subject which requires a separate inquiry. Again, our notion of fire is popular, and of no use, being made up of the combination in any body of heat and brightness, as in common flame and bodies heated to redness. Having thus removed all ambiguity, I come at length to the true specific differences which limit motion and constitute it the form of heat. The first difference, then, is this. Heat is an expansive motion whereby a body strives to dilate and stretch itself to a larger sphere or dimension than it had previously occupied. This difference is most observable in flame, where the smoke or thick vapour manifestly dilates and expands itself into flame. It is shown also in all boiling liquid which manifestly swells, rises, and bubbles, and carries on the process of self-expansion till it turns into a body far more extended and dilated than the liquid itself, namely into vapour, smoke, or air. It appears likewise in all wood and combustibles, from which there generally arises exudation and always evaporation. It is shown also in the melting of metals, which, being of the compactest texture, do not readily swell and dilate, but yet their spirit being dilated in itself, and thereupon conceiving an appetite for further dilation, forces and agitates the grosser parts into a liquid state, and if the heat be greatly increased, it dissolves and turns much of their substance to a volatile state. It is shown also in iron or stones, which, though not melted or dissolved, are yet softened. This is the case also with sticks, which when slightly heated in hot ashes become flexible. But this kind of motion is best seen in air, which continuously and manifestly dilates with a slight heat, as appears in instance 38, Table 3. It is shown also in the opposite nature of cold, for cold contracts all bodies and makes them shrink, insomuch that in intense frosts nails fall out from walls, brazen vessels crack, and heated glass, on being suddenly placed in the cold, cracks and breaks. In like manner air is contracted by a slight chill, as in instance 38, Table 3. But on these points I shall speak more at length in the inquiry concerning cold. Nor is it surprising that heat and cold should exhibit many actions in common, for which see instance 32, Table 2, when we find two of the following specific differences, of which I shall speak presently, suiting nature, though in this specific difference, of which I am now speaking, their actions are diametrically opposite. For heat gives an expansive and dilating, cold a contractive and condensing motion. The second difference is a modification of the former, namely that heat is a motion expansive or toward the circumference, but with this condition, that the body has at the same time a motion upward. For there is no doubt that there are many mixed motions. For instance, an arrow or dart turns as it goes forward, and goes forward as it turns. And in like manner the motion of heat is at once a motion of expansion and a motion upward. This difference is shown by putting a pair of tongs or poker in the fire. If you put it in perpendicularly and hold it by the top, it soon burns your hand; if at the side or from below, not nearly so soon. It is also observable in distillations per decensorium, which men use for delicate flowers that soon lose their scent. For human industry has discovered the plan of placing the fire not below but above, that it may burn the less; for not only flame tends upward, but also heat. But let trial be made of this in the opposite nature of cold, viz., whether cold does not contract a body downward as heat dilates a body upward. Take therefore 2 iron rods, or 2 glass tubes, exactly alike, warm them a little, and place a sponge steeped in cold water or snow at the bottom of the one, and the same at the top of the other. For I think that the extremities of the rod which has the snow at the top will cool sooner than the extremities of the other which has the snow at the bottom, just as the opposite is the case with heat. The third specific difference is this, that heat is a motion of expansion, not uniformly of the whole body together, but in the smaller parts of it, and at the same time checked, repelled, and beaten back, so that the body acquires a motion alternative, perpetually quivering, striving and struggling, and irritated by repercussion, whence springs the fury of fire and heat. The specific divergence is most displayed in flame and boiling liquids, which are perpetually quivering and swelling in small portions, and again subsiding. It is also shown in those bodies which are so compact that when heated or ignited they do not swell or expand in bulk, as ignited iron, in which the heat is very sharp. It is shown also in this, that a fire burns most briskly in the coldest weather. Again it is shown in this, that when the air is extended in a calendar glass without impediment or repulsion, that is to say, uniformly and equably, there is no perceptible heat. Also, when wind escapes from confinement, although it bursts forth with the greatest violence, there is no very great heat perceptible, because the motion is of the whole, without a motion alternating in the particles. And with a view to this, let trial be made whether flame does not burn more sharply toward the sides than in the middle of the flame. It is also shown in this, that all burning acts on minute pores of the body burnt, so that burning undermines, penetrates, pricks, and stings the body like the points of an infinite number of needles. It It is also an effect of this, that all strong waters, if suited to the body on which they are acting, act as fire does, in consequence of their corroding and pungent nature. And this specific difference, of which I am now speaking, is common also to the nature of cold. For in cold the contractive motion is checked by a resisting tendency to expand, just as in heat the expansive motion is checked by a resisting tendency to contract. Thus, whether the particles of a body work inward or outward, the mode of action is the same though the degree of strength be very different, because we have not here on the surface of the earth anything that is intensely cold. See instance 27, Table 1. The fourth specific difference is a modification of the last. It is, that the preceding motion of stimulation or penetration must be somewhat rapid and not sluggish, and must proceed by particles, minute indeed, yet not the finest of all, but a degree larger. This difference is shown by a comparison of the effects of fire with the effects of time or age. Age or time dries, consumes, undermines, and reduces to ashes no less than fire, indeed with an action far more subtle. But because such motion is very sluggish and acts on particles very small, the heat is not perceived. It is also shown by comparing the dissolution of iron and gold. Gold is dissolved without any heat being excited, while the dissolution of iron is accompanied by a violent heat, though it takes place in about the same time. The reason is that in gold the separating acid enters gently and works with subtlety, and the parts of the gold yield easily, whereas in iron the entrance is rough and with conflict, and the parts of the iron have greater obstinacy. It is shown also to some degree in some gangrenes and mortifications, which do not excite great heat or pain on account of the subtle nature of putrefaction. Let this be the first vintage or commencement of interpretation concerning the form of heat, made by way of indulgence to the understanding. Now from this our first vintage it follows that the form or true definition of heat, that is, in relation to the universe, not simply in relation to man, is, in few words, as follows. Heat is a motion, expansive, restrained, and acting in its strife upon the smaller particles of bodies. But the expansion is thus modified. While it expands all ways, it has at the same time an inclination upward. And the struggle in the particles is modified also. It is not sluggish, but hurried and with violence. Viewed with reference to operation, it is the same thing, for the direction is this. If in any natural body you can excite a dilating or expanding motion, and can so repress this motion and turn it back upon itself that the dilation shall not proceed equably, but have its way in one part and be counteracted in another, you will undoubtedly generate heat, without taking into account whether the body be elementary, as it is called, or subject to celestial influence, whether it be luminous or opaque, rare or dense, locally expanded or confined within the bounds of its first dimension, verging to dissolution or remaining in its original state, animal, vegetable or mineral, water, oil or air, or any other substance whatever susceptible of the above-mentioned motion. Sensible heat is the same thing, only it must be considered with reference to the sense. Let us now proceed to further aids. End of Aphorisms 14 to 20 of Book 2.